Reddy Maths YouTube channel. Teacher and teaching assistant training in mental multiplication. We're now up to day 4, and today we're going to be looking at the strategy of round and adjust.
Hello and welcome back to the Ready-Made Mathematics classroom for another week of Ready-Made Mathematics training. Last week, obviously we had a break for half term, but we did have one bonus video, which I hope you've had a look at. That's still running for this week, and that's the competition. There's a competition to win a full set of 15 Propeller Rapid Recall whiteboards. So if you've not checked that out, please have a look on the YouTube channel and check out the competition. And obviously, you've got until Friday to enter that for a chance to win. There was one video yesterday where we looked at division, and that was the one that I promised for quite a few weeks. And we looked at the bus stop method of division and how that can be really taught with understanding through mathematical apparatus and visuals. What we're going to be looking at today is a continuation of the strategies that we started practicing before half term for mental multiplication. We had an introductory video where we looked at all of the individual strategies just very briefly. And then we had 2 days where we looked at the first 2 of the strategies. We started off with reordering, which is kind of the mental multiplication version of number bonds, where you reorder the multiplication calculation so that it's easier to solve. The second day we looked at probably the key strategy for any mental multiplication, kind of the default strategy, which is partitioning. The strategy that we're particularly going to be looking at today is the strategy of round and adjust. That was a strategy that we did use for a mental addition, where we kind of added 9 by adding 10 and taking 1. We added 19 by adding 20 and subtracting 1, and so on. We added 197 by adding 200 and subtracting 3. So it is a strategy that we have practiced for mental addition. But what we're doing in this particular video is we're taking it a stage further. We're going to look at how a round and adjust can be used for multiplication. So rather than having to partition, if a number is specifically set up in a certain way, you'll recognise something about the number similar to with addition, that it usually ends in a 9 or an 8. And there should be a way to make the calculation easier to solve. It's very similar to when you go shopping and you buy, I don't know, 3 items for £1.99 a piece. If you want to know how much that's going to be, you're not going to say 3 times £1, 3 times 90 pence, 3 times 9 pence and add them together. You'll go 3 times £2 is £6 and take off your 3 pence to get £5.97. So it's that sort of idea where we're looking at a number and we're rounding it to make the calculation easier. But as with all of the other strategies, what I also want to do is make sure you've seen a visual. So if you're teaching this to children in Key Stage 2, usually around about year 4 upwards for this one. But again, it could be done slightly earlier. But if you're teaching children this strategy, let's make sure they understand it first through a visual. Then we can develop it, and eventually it will become something that they'll just be able to use as a mental strategy. So to begin with, what we're going to do is have a quick look at some of the resources on the table. I've set out quite a few different variations of calculation. What we're going to do is we're going to take a quick look at them, and then we're going to look at how they could be developed a visual picture of round and adjust using concrete apparatus. So what I'm going to ask you to do is to look at each of the images that you're going to see shortly and try to work out what are they representing. There's the first one, there's the egg boxes. We're going to move along from the egg boxes to actual tens frames. What number can you see there and what's represented? We're then going to move to egg boxes again, but this time with much bigger numbers in. Can you see what number's there and how many times that number is represented? We'll move over to base 10, which allows us to represent bigger numbers much more easily. There are 2 different numbers there. You can see the simple base 10 at the left hand side and then a slightly bigger number on the right hand side. What calculation do you think each of those represents? Let's now move up to the numicon. What numbers can you see there with the numicon? And finally, have a quick look at the abacuses. Now I'm going to bring the camera down a little bit there so you can see the abacuses a little bit more clearly. What number can you see on each of the abacuses? Hopefully there's a connection between all the numbers, but it's nice just to get those pictures in our heads to begin with. So beginning with the first image, hopefully what you can see, if I just separate them slightly, is you can see 3 tens. you can see 10 multiplied by 3. Now we don't really need multiplication for that. 10, 20, 30 straight away. But what about if I was to take a cube out, take another cube out, and take another cube out? Have a look now. Now hopefully what we can see now are 3 9s. Calculation's changed. It's gone from being 10 multiplied by 3 to now being 9 multiplied by 3. How do I work the answer out? Just pause for a second. Obviously we might know the answer, but if we don't know the answer, how could I work it out quickly? I'm hoping what we can see is we originally had 10, 20, 30, or 3 10s. We've removed 1 from each, so what we've now got is 9 multiplied by 3 is 27 because we've got 30. Subtract 3. So 10 multiplied by 3 is 30. That's if we've got all of the boxes full. We take 1 cube out of each, it's 30. Minus 3 is 27. What we can see now are 5 tens frames. Each of those tens frames slightly different to the consistent image we've just seen, but they all do show the same number. What number can you see? What does it tell you about that number? What's the calculation you're being asked to do? And how can we work the answer out really quickly? Hopefully you can see straight away all of those tens frames, first, second, third, fourth and fifth, are all the number 9. How do we know it's 9? We're going right back to that early years activity. We know it's 9 because it's 1 less than 10. It's 1 less than 10, it's 1 less than 10, it's 1 less than 10, and it's 1 less than 10. So we can straight away see each of those is the number 9. How many black dots can you see altogether? Well, I certainly don't think you'd count them all. You wouldn't separate them all into 5s and 4s or 5s and 3s and 1s. You'd look at it and go, well, 10, 20, 30, 40, 50. 50 if they were all full. There's 5 spaces. 50 subtract 5 is 45. Now, obviously, at some point we'll know that 9 times 5 is 45. But let's imagine we didn't. Let's ask a child in year 3, how could you work that out really quickly? Could they go, oh, it's just 50 minus 5? Could they see that straight away? Because if they can, they're then getting into the idea of the round and adjust strategy. Hopefully this next one is much, much easier. What can we see this time? Hopefully we can see 2 10s or 20 repeated 3 times, or 20 multiplied by 3. 20, 40, 60. So we can do 20 and 20 and 20, or just 20 times 3 is 60. But remember all the time that link to 2 times 3. Because actually that's what we're also seeing. We're seeing 2 10s multiplied by 3. How many 10s can we see? 6. So you can always make that link. That is actually 2 times 3 in 10s, or 20 times 3. What we're now going to do is we're going to pause the video and we're going to change it slightly. So what's happened now? Well, we've replaced one of the 10s, as you can see there. We've just taken 1 off each and replaced each of the 10s with a 9. How do we know it's 9? We know it's 9 because it's 1 less than a 10. And we can see that 1 space at the top. Now the calculation's got considerably harder unless we use round and adjust. If we use partitioning, we've got 10 times 3 is 30, 9 times 3 is 27, 30 and 27 is 57. But if we use round and adjust, what can we actually see? We can see 1 less than 20, 1 less than 20, and 1 less than 20. As before, 20 multiplied by 3 is 60, subtract 3 is 57. I think children would see that straight away. I think if you were to ask them to, to try and work out a quick way to do that, I think a lot of children will be able to see that visual and then be able to start to use the round and adjust strategy. Your turn now. I've created a brand new calculation using base 10. All I want you to do when I pause the video is to look at what you can see first of all. So what's the number? How many times have we repeated that number? How can I use round and adjust to work out the answer really quickly? Off you go. What we can see is 49 multiplied by 4. How do we know it's 49? Well, we can see 4 10s, and then we can see 1 less than 10 on each one, or 4 10s and a 9. 49 multiplied by 4. How are we going to work that out? We're not going to do a partition, although we could. 4 40s are 160, 4 9s are 36. Add them together to get 196. That's our default strategy from last time. But what we're going to do now is make it much easier. Let's just imagine that each of those 9s had 1 more on them, and we actually had 50. 50 multiplied by 4, 200. But we can see there are 4 spaces, or 4 missing, so we subtract the 4. 50 times 4, 200. 200 subtract 4, 196. Really, really quick and just backed up by that visual all the way. Let's have a quick look at that calculation as a jotting. Well, it could be written very simply as 50 times 4, or 50 multiplied by 4, subtract 4, or just written as 200, subtract 4. Some people will put brackets around the 50 multiplied by 4. So you can do that part first of all. You don't really need brackets there, but a lot of people would see it, make it easier by putting the brackets in. But 50 multiplied by 4 is 200, subtract by 4, 196. Simple little jotting. Eventually though, it just gets done in your head. We won't do 49, we'll do 50, and then we'll subtract the 4. Now this one is a little bit more complex to look at, but hopefully what we can see on this one is the number 18 repeated 5 times, or 18 multiplied by 5. Again, I'll very quickly pause the video, just have a quick discussion. How would you do this one using the strategy of round and adjust? We've no longer got a number that ends in a ones digit of 9, it now ends in a ones digit of 8, but it's 18 repeated 5 times. I think the key question is, what can you see? What do you notice each time? And how can that help you do this calculation really quickly? Again, pause the video, have a think, and then we'll have a quick look. So fingers crossed, what we can see here is actually the number 20 5 times, but each time there are 2 spaces or 2 missing. So if I focus just specifically on the black and white ones down there, we can see 10 blacks and 8 whites. We can see the number 18. What we can also see is 20 subtract 2. There's another 20 subtract 2, a third, fourth and fifth. We've got 5 20 subtract 2s. So 5 20s, well 5 20s, 20, 40, 60, 80, 100. And then we subtract 2, 4, 6, 8, 10. 100 subtract 10 is 90. So a really simple way of doing it, just using the idea of round and adjust. Just to focus on how we could jot down that one, 18 multiplied by 5. I'm just going to show you 2 ways. I tend to always use the word multiply and always write the number that we're multiplying first. So 18, and then we're going to multiply it by 5, or we're going to repeat it 5 times. So we take the first number and use multiplication kind of by repeated addition that particular way, or by scaling. We make 18 and we make it 5 times as big. So if we do it that way, you can see that 18 multiplied by 5 becomes 20 multiplied by 5, subtract 2 multiplied by 5. Because there is basically 20, subtract 2, 5 times. You end up with 100 subtract 10 equals 90. A lot of people though might record it differently. They may record it as 5 multiplied by 18 using the term lots of. 5 lots of 18. So we've got 5 lots of 20, 5 times 20, subtract 5 lots of 2, 5 times 2. You still end up with 100 subtract 10. I far prefer to use the term multiply. I think we're doing multiplication, we're not doing lotsification. So I tend to think multiply is the correct word to use. So personally, I would always record it the top way. But again, it's not mathematically incorrect to record it the other way. It's just an alternative approach. Whichever one you prefer. 5, 6, 28 multiplied by 6. So how we're going to do it? Well, hopefully we can. I think this is a lovely view on the Numia because I think you can see those spaces straight away. We can see that 28 is 2 less than 30. So if I look at this one down here, we can straight away see those 2 spaces. I can see 10, 28, but I can also see 10, 20, 30, subtract 2, 30 subtract 2. So what have we got? We've got 30 multiplied by 6 is 180, and we've got to subtract 2, 4, 6, 8, 10, 12. So 180 subtract 12 is 168. Let's bring that one into play. I always think it is worth writing exactly what they're doing until the children get used to the strategy. Otherwise, they often forget which bit you take off. So let's write down what we're doing. Well, we can see 30 multiplied by 6. And we can also see that there are 2 spaces each time. So we're going to subtract 2 multiplied by 6, which will give us 180 subtract 12. Eventually, the children will just look at the number at the top and go, 6 30s, 180, subtract 6 2s is 12, 180, subtract 12. But that takes a while, so I would initially just write down the whole thing to help the children out. Now looking at the final set of visual images, this is just quite a nice, interesting one using the abacuses. We'll just talk this one through really quickly. What can we see? Well, I'll look at the first abacus over there. And we can see it's almost full, but if we look down here, we can see there are 2 missing. So if the abacus was full, it will be 100. but it's actually 98. It's 98 multiplied by 1, multiplied by 2, multiplied by 3. 98 multiplied by 3. Really quickly, how we're going to work that out. So what are we going to do? We're going to imagine that they're all complete. We have 100, 200, 300, and then we just subtract 6. 300 subtract 6 is 294. How easy is that? 98 multiplied by 3 is really 100 times 3, 300, subtract 2 times 3, 6. 300 subtract 6, 294. Okay, I think it's time to have a quick go yourselves now, a series of different calculations. I've written on the board 5 calculations that all need to be round and adjusted. They start off relatively easy with 19 times 4, 59 multiplied by 3. Then they get a little bit more complicated as we move down. So again, just very, very quickly, jot down, you can either jot down the whole thing as we've done on the whiteboards, or you can just look at it, work out the answer, and just jot down the answer. Entirely up to you. Off we go. So let's have a quick look at those calculations. Hopefully they weren't too difficult if we use the idea of round and adjust. We'll start off with 19 multiplied by 4. 19 multiplied by 4, well 19 is very close to 20, so we'll do 20 multiplied by 4 is 80, and then we'll just subtract the 4. 20 multiplied by 4, I'll put it in brackets, is 80, subtract 4 is 76. This one we'll just do mentally, I won't even write the jotting down. 59 times 3, 60 times 3, 180, because we know 6 times 3 is 18. We've always got to use that idea. If we know 6 times 3, that will get us to 60 times 3. So 60 times 3, 180, subtract the 3, 177. So again, very, very quick. Moving on, still doesn't get much more complicated. 79 times 5. Well, we know 79 is 1 away from 80, so we're imagining we've got 80 times 5, 80 multiplied by 5. Well, 8 multiplied by 5 is 40. We've now got 8 tens multiplied by 5 is 40 tens, or 400. 400, so we'll write the 400 down, and we're going to subtract 5. So you can see there are 3 different ways that we could jot it, depending on where we are. If we need all of the structure, let's write everything down. If we want to just work the answer out in our head, we just jot down 177. Or if we want to do kind of something in between, 80 times 5 is 400, subtract 5 equals 395. You'll notice with all of these I've chosen to use a ones digit of 9. We're going to extend that shortly. We've now got 39 multiplied by 7. Well, 40 times 7 is 280. Subtract 7. That tends to be my favourite jotting of the 3, rather than just writing the answer down. 280 subtract 7 equals 273. What I would then ask a lot of children to do is just double check by partitioning. Just check as well, so we can practice another of the skills as well. 7 times 30 is 210. 7 times 9 is 63. 210 and 63 is 273. So if you want to take your children to more depth, obviously do the round and adjust as the quick strategy. Double check it and jot down the partition as well. Finally, 89 multiplied by 8. What can we do for this one? Well, for this one, we'll make the 89 into 90. I'll write the whole thing down this time. 90 multiplied by 8, and then we're going to subtract 8. 90 times 8, jot it there, is 720. 720, subtract 8 is 712. Let's double check. 640 and 72 if we use the partitioning strategy. So that's just using, obviously, a ones digit where it's a 9. What I want to do now is I want to rub all these off. I want to set some new calculations up. I want a quick practice using round and adjust with slightly different numbers. Okay, so these are considerably more complicated. We're now moving really into upper key stage 2, but using exactly the same strategy. I've not moved on to decimals yet, or onto money, but I'll just have a quick look at those and just see. Again, pause the video, have a look, jot down any way you want, any of the preferred jottings, and see if you can work those out using the strategy of round and adjust. Let's have a look then. 299 times 3. Again, this one does end in a 9, so this one should be a little bit easier than the others. 299 is very close to 300. 300 times 3 is 900. And then we subtract the 3. because we want 299 times 3, not 300 times 3. So that gives us 897. Again, we could check by partitioning, but I think at this point, let's just make sure we've got these correct. The next one, 58 multiplied by 6. Now it's getting a little bit more complicated. 58 multiplied by 6, so we're going to imagine we've got 60 multiplied by 6 to begin with. And then what we're going to subtract is what? What do we subtract this time? Well, we're subtracting 2, because 58 is 2 away from 60, so we're going to subtract 2 multiplied by 6. So, again, you can do that in 2 stages. 60 times 6 is 360. Subtract 2 times 6 is 12. 360, subtract 12 is 348. We can always check 360, sorry, 300 add 48. So that one actually is a very easy partition as well. So that's a relatively straightforward one to do. 48 multiplied by 9. So again, what we're going to do for this one, we're going to make it 50 times 9. So 50 times 9 is 450. And we're going to subtract, this time, 2 times 9, which is 18. A little bit harder, but 450, subtract 18. When we subtract 10, we get 440. And subtract 8, we get 432. Or we could have subtracted 20 and added 2, if you don't want to do it that way. Again, just double check. 360 and 72 is 432. Now, this is where, would you use round and adjust? I don't know. 68 multiplied by 7, I think you probably still would. 68 multiplied by 7, or 70 times 7, write down the whole thing. 70 times 7, which is 490. And we're going to subtract 2 times 7, because we don't want 70 repeated 7 times, we want 68, so we want 2 away from that. So subtract 14, and that will give us 476. Even as the numbers get really big, 698 multiplied by 4, I'm definitely going to do that with a round and adjust. It's a massive number to deal with as a partition, or as a standard method. You can obviously do it as a column method, but I'm just looking at that and going, well, 700 times 4, it's just the same as 7 times 4. 7 times 4 is 28. 70 times 4 is 280. 700 times 4 is 2,800. Just make sure we subtract the right thing. We subtract 2 multiplied by 4, so we subtract 8. 2,800, subtract 8 is 2,792. And finally, 997 multiplied by 3. What do we do with that one? This one is 1,000 times 3, so it's 3,000. And I'm subtracting, what am I subtracting this time? Well, I'm actually 3 away from 1,000, so I've got to subtract 3 times. So I'm just going to subtract 9. So 3,000, subtract 9. Hopefully that one's not too complicated. Gives us 2,991. I could be crazy and practice it with a partition. 2,700, add 270, add 21, and you will still get the same answer. But hopefully the more you practice that strategy, it becomes one you'll just start to do mentally. It's a brilliant one for shopping lists, as you're going around shopping, just mentally adjusting in your head as you're doing it. And it's a really cool strategy to support mental calculation. So we're going to finish off just by looking at a couple of little decimal examples. What we've now got, just a couple of little decimal examples to try the same strategy. 2.9 multiplied by 6, that's 1/10 away from 3. So we're going to start off with 3 multiplied by 6. 3 multiplied by 6 is 18, but remember, we don't want 3, we want 2.9. So we've got a 10th. Imagine 2 wholes and 9/10 repeated 6 times. So it's 3 repeated 6 times, subtract 1/10 repeated 6 times. So all I subtract is 0.6. 18 subtract 0.6 is 17.4. And great for children in year 5, and particularly in year 6. Even with this one, we can do this one by a partition as well. But let's just try the round and adjust. 6.8 times 4. Well, 6.8 is 2/10 away from 7, or 0.2 away from 7. So we'll just write it down. We're at 7 times 4. And we're going to subtract. We're 2/10 away, so we subtract 0.2 times 4. With that one, we get 28. And we subtract 0.8, which gives us 27.2. Let's just double check. 4 times 6 is 24. 8/10 times 4, or 0.8 times 4 is 3.2. So 24, add 3.2 is 27.2. So again, both strategies work, but again, round and adjust, great for decimals. Thank you so much for joining me for the round and adjust video. What we're going to be doing tomorrow is a much shorter video tomorrow. We're going to be looking at the strategy of factorising, which is quite a brief one to do. So we're going to have a quick look at what factories actually are. And we're going to take that idea and we're going to use factorising to help us do certain multiplications. But I really hope you found today useful. There should have been a clear link between the addition round and adjust video. And if you haven't seen that, please go back to week 1 and have a look at that. And obviously today's video where we've taken round and adjust and applied it at key stage 2. So for years 4, 5 and 6, let's get that idea of not always having to partition, not always having to write down a written method. We get a calculation, 29 times 4, 30 times 4, subtract 4, and so on. So hope you've enjoyed today's video and I'll look forward to seeing you tomorrow. Thanks very much.
And thank you so much for joining me today for the video on rounding and adjusting. Hope you've enjoyed it. Tomorrow we're going to be looking at the strategy of factorising. I look forward to it and I'll see you then.